little video I'm just going to make for you just to show you a couple of things that may be useful that I'm getting a few different questions on. So I'm just going to quickly show you an example based on this question here, which is one of the GCSE questions that I cropped out for you. Please excuse my hair this morning, just out of the shower. We're going to do this one, and I'm just going to talk you through a couple of useful little things which we haven't already covered that may be helpful. So I'm onto my graph. I see this question. I'm going to add a graph as we've been doing. I'm going to add my lined grid, so make sure I go to show and I show my lined grid, and then I'm going to input my function. All of these we have covered in previous videos. So I enter my function, which is going to be 5x to the power of 4 minus x to the power of 5. Now when I put this graph in, it looks something like this, and if you look at the top of the graph, it kind of cuts off. Again, it goes down and then there's a line. But when I look at the scale on my question, it actually gives me a y and an x scale that are vastly different to the negative 10, 10, 6.67, negative 6.67 I've got here. So what I'm going to do is I'm going to set the graph up so that the scale matches that in the question. So what that means is I want it to go on the x and y axis to match. So I go to my menu and I go to window zoom and I go to window settings. And what this allows you to do, don't worry, we can leave the scales as auto, but it allows us to match the graph on the sketch here to the graph that we want here. I can see that when I look at this one, it goes from negative 2 to 5.2. Negative 2 to 5.2. It also goes from negative 150 to 300 on the y-axis, so I want to match this on my scale. Leave the x and y scale as auto, then it will automatically do it nice intervals for you. Click OK, and you can now see that the graph much more accurately reflects what we want it to look like in the sketch. And you can see because the scale on the calculator and the scale on the sketch are the same thing, then the shape will look as we want it. We can then use this to find different things. So for example, first of all, ask us for a maximum. We can see that now we've got the whole graph in view. We actually can see where that maximum is, and just like we've done before, we can analyze the graph and do a maximum. And we can do it something like this here. For the minimum, it's going to be hard to use the minimum tool because we can't go over the space where it is because it's right at the edge of the graph. So what we can do is we can use our point on line tool like we were doing before. So geometry, points and lines, point on. And we can click on the graph. And we know that it's going to be right at the end, which we know is x is 5.2. That's the edge of the graph. So I can set this to be negative 5.2. Oh, I did negative 5.2. I should have done positive 5.2. Sorry. It's positive 5.2, sorry, which is there. And now we can see these as the local minimum and local maximum, and the range is, of course, the distance between them. So that's a couple of things that we can do that we haven't already showed. We can also find the zeros by, again, we can see that they're going to be somewhere on here. We could use our intersection tool, or we could use our point on. The local maximum we've done, the range, of course, the distance between them, and again, oh sorry, I'm just going to move my little face. It says the equation fx is k, where k is an integer, has one solution. Write down a possible value of k. Well, of course, you've got lots of different options there, and you can use your graph, can't see my face, to find values of k. So again, we could use our point on line tool. And we could say, well, when is f of x an integer? Well, there's an example, 4256. So I shall leave this video there. Just remember, like I said, key thing to learn from this one is that scale tool, using the window zoom and setting up your window so that it matches, as our graph is here, match the scale in the calculator to the scale they want you to sketch. And that way, when you've done that, it gives you the correct shape of the graph. If you don't do that, then it gives you a wildly, if I just keep undoing, Okay, it gives you a wildly different shape, which we don't want.